finished crafting this year. The model is called PSKEEB, which means it's the 5th generation design in the PSKEEB series. So what do you think? Pretty sleek, right? I've been into ergonomic keyboards for 8 years now. At first, I was into keyboards like the Doctor, the one with tons of keys and really unique shapes. But after using them for a while, I realized when I travel for work or when on vacation, it's really hard to lug this big thing around. But because I was already used to the layout, I still wanted a keyboard that can handle both my daily work and my need when traveling. So that's how the PSKEEB series was born. Now the P in PSKEEB stands for Portability. So keyboards in this series are in a compact form factor. They are basically all 36 key designs and symmetrical, so they can be stacked together to reduce the space furthermore. The case is 3D printed. One advantage is that you can get really creative with the shape, and another is they are actually pretty light. Next, the S stands for split. As a seasoned programmer, I suffer from all kinds of RSI issues. So to last longer in this career, a split design is absolutely essential. Also, having a tilt is part of the ergonomic design. One thing not reflected in the series name is efficiency. Programmers are a group that naturally pursues efficiency. Plus, I'm a pretty impatient person, so this characteristic is something I consider in everything I make. It is always a hidden must-have requirement. In this keyboard series, that is reflected in the 36 key design. Why are 36 keys considered the most efficient? Let's first look at a regular keyboard. This one has a 68 key layout, which is considered relatively small form factor among mass-produced keyboards you can buy. Now, when I use a keyboard like this, I always find it is error-prone. Using my pinky to tap these keys, especially the 0, minor, and the equal keys. I often press the wrong one even after decades of practice. Maybe my fingers are just too short. But what if we can type them without stretching our pinkies? Say, for example, when I want to input 0, I hold the space and press U for 0, and correspondingly press I for a minor sign or O for the equal sign. My chance of pressing the wrong key drops dramatically. Our fingers don't have to stretch as far. You can keep them mostly in the home row area to complete all our typing. Now, what about even fewer keys? For example, less than 36? Well, thanks to Ben Verloc, had done it for us. According to his conclusion, it was quite error-prone and requires too much mental overhead, which actually makes it less efficient. So 36 is just right. It is the sweet spot where fingers can comfortably reach without being too few. Some people might wonder, how can 36 keys possibly be enough? After all, a standard keyboard has over 100 keys. The solution is actually pretty simple. Let's look at this 68 key layout. It has an FN key. Typically, the design is like this. You hold the FN and then press another key. On this keyboard, for example, holding FN and pressing O makes it a immediate stop key. It is the same principle with a 36 key keyboard. You can assign it so holding a certain key and pressing O outputs a different key. Using this method, we can input the full set of 100 plus keys or even more. Keys you can't find on a regular keyboard can also be input, as well as key combinations and so on. Another thing I find inefficient about mass-produced small keyboards is that the key layouts are preset. You can't change them, you just have to get used to them. But in reality, everyone's work environment is different. The software we use is different, and everyone's habits are different too. So the layout they designed might not be the most efficient for you. All keyboards in my series use open source firmware, and they all support remapping key via a web interface. These changes are saved directly on the keyboard's hardware, so when you plug it into another computer, they are still valid. This little checkpoint is partly for portability. It can replace a mouse when you are on the go. But more importantly, when I need to use a mouse while coding, having it right on the keyboard is just more efficient. My hand doesn't need to leave the keyboard. Up until the fourth generation, this series was wire only, because the firmware and the GUI tools were already quite mature and feature complete. No need to jump into the deep end right away, right? Start with the simple stuff is my way to go. But for the fifth generations, I wanted to challenge myself a bit, so I tried using the GMK firmware for a Bluetooth dual mode keyboard. Yep, I fell into quite a few pitfalls and put it a lot of effort, but I finally managed to pull it off. This new storage box also doubles as a laptop stand. It raises the screen a bit, which is friendlier on our necks. Helps me keep my head up. Finally, let me share some thoughts on open source. Actually, I have been open sourcing this entire keyboard series on GitHub. But open sourcing, well, the source code and diagram are one thing. What takes even more time and effort is documenting each step clearly so others can follow along and actually build the whole thing. So yep, let's see how much interest there is. If enough people are interested, I'll organize everything and get it open sourced as soon as possible. So please hit that like button, subscribe and share.